Okay, in this lesson I'm going to use Newton's method to kind of figure out the roots of this function. Now, actually, this function would be very easy to find the roots. X squared minus 7, very simple to find the roots. The actual roots, we set x squared minus 7 equal to 0. Solving, we see that x could be plus or minus root 7. Okay, so there's two roots plus or minus root 7. Okay, x squared minus 7 equals 0. So that's one thing to bear in mind. That's the actual root. Root 7 is an actual root. Negative root 7 is an actual root. Okay, so I want to use Newton's method just to show how it works with a simple function, and then I'll look in the next lesson at a slightly more complicated function. So f of x equals x squared minus 7, and x sub 1 is equal to 3. So we're asked to complete two iterations of Newton's method for the given function, an indicated initial guess. So what's happened here is somebody said to me, what is the root of x squared minus 7? What value can I plug in to make that equal to 0? And I've come up with this guess, which I suppose on one level is kind of ridiculous. I've come up with this guess, and I'm going to say 3. 3 is a root. So I'm guessing that 3 squared minus 7 is 0, which of course it's not, but it's a guess. When we're dealing with more complicated functions, a guess is important. In this case, I could tell you exactly. Root 7 squared minus 7 will give me 0. But I'm going to guess. You're imagining I've made this poor guess of 3. Okay, that's my first guess. That's x sub 1. Newton's method says, and again, let me just whip out the formula here, that x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n. So to use Newton's method, one thing I have to know is the derivative of the function. So if I take the derivative of f of x, what we get is 2x. Okay? My first guess, x sub 1, is 3. What we're going to do now is find x sub 2, which is also always going to be x sub 1. Notice if the index is 2, well, that means n plus 1 is 2, so n is 1. So this will be x sub 1, index there of 1, minus f of x sub 1 divided by f prime of x sub 1. This is what Newton's method says. So what I'm going to do to find my approximation for the actual root is my second approximation. My first one was a guess of 3. My second approximation, which should be better, is I'm going to take the value of 3 and then I'm going to subtract from it the value of the function at 3 and the value of the derivative at 3. Okay? So x sub 2 is equal to x sub 1, plugging in here. We know that x sub 1 is 3, minus f of x sub 1, well, that's f of 3, divided by f prime of x sub 1, which is f prime of 3. So just substituting in. F of 3, well, plug 3 in here. We get 3 squared minus 7. Let me write that in exactly. So that's going to be 3 squared minus 7. Over f prime of 3, well, f prime says double the input. That's going to be 2 times 3. So what I'm getting is 3 minus, and then on the top here I've got 9 minus 7, which is 2. And on the bottom here I have 2 times 3, which is 6. 2 6 1/3. And so I'm going to say 3 minus 1/3. Well, that's 2 and 2/3. Or if you prefer, 2.6 recurring, depending on whether you prefer decimals or not. So that's x sub 2. And you're going to find that's closer to being the actual root. Remember, the actual root is root 7. Okay? But if we know the actual root, it's kind of a pointless operation. But I'm just using it to show you how it works. To find my third approximation for the root, I'll follow the formula. Here, n plus 1 is 3. The index is 3. So the index of this term will have to be 2. So it's going to be x sub 2 minus f of x sub 2 all over f prime of x sub 2. So in other words, well, x sub 2 is what? 2 2/3. Maybe I might write this. I prefer to write this as a single fraction. So I think it's 8/3. So x sub 2 here is 8/3 minus f of 8/3 all over f prime of 8/3. Okay, so it's going to be 8/3, and then we just plug 8/3 into the function f, which is x squared minus 7. So 8/3 squared minus 7, all divided by f prime of 8/3, which is just doubling 8/3. Now at this stage, you might just decide to use a calculator just to tidy things up. Okay, if you don't, your mental arithmetic will need to be pretty good. You're going to square 8/3, which is 64/9 on the top. On the bottom, you get 2 times 8/3, which is 16/3. Let's do it without a calculator, but again, I do emphasize you don't need to do this. So 8/3 minus, here we'd have 64/9, squaring that, 64/9, minus 7, well 7 is 63/9, so I might just write that like that, all divided by 2 times 8/3, well that's 16/3. Simplifying here, I'm going to get 8/3 minus, on the top 64/9 minus 63/9, that's 1/9. And dividing by 16/3 is the same as multiplying by 3/16. A little bit of cancellation here. 3 will cancel with that. 9 leaving with 3/16 on the bottom. Okay, so what I'm going to get here, let me move this down a little bit. 8/3 minus 1/48. Okay. Common denominator there is 48. 3 goes into 48. I think 16 times 8/16 is 80, and 48, I think that's 128 minus 1. So I think I'm getting 127/48. You might just double check all my arithmetic there. Of course, you don't need to do it by hand. You can just type it all into your calculator. That's working out, you know, if you type that into your calculator, which I have done here, that's, you know, approximately equal to 2.646. Okay, so it's a closer root. Now, if you put in the actual root, and I really encourage you to do this, if you actually go in and put in the real root, the actual root of this, which we know is root 7 is actually equal to 2.64. And if I round to 3 decimal places, let me say it's approximately equal to 2.646. So even after just 2 iterations there, we found a value that's extremely close to the actual root, which is 2.646. Okay? My next video I'll put up will be on how to use Excel to do a whole load of iterations really quickly using Newton's law.